In this video, we're going to talk about solving a problem three different ways. And one is circuit reduction, second will be KVL, and the third one will be your voltage divider. And you'll see you will get the same answer. So in this series, in these three video series that we'll have, we'll talk about how one circuit is solved in multiple different ways, and that's what you generally have in circuit analysis or any kind of physics or engineering. There's different approaches and different methods. So here, okay, here we have a resistor. Obviously, we're going to one resistor. After some practice, we should be able to do this. This obviously is, in this circuit, is a series circuit, right? And the series circuit is going to break into two resistors like so. So we're just going to go ahead and take these two resistors and make it into one resistor. Call this RS is equal to R1 plus R2. 10 plus 5 is 15 ohms. Okay, now this obviously goes here, right? We're going to take a simple RS value here, and we're just going to do this, right? So we can solve for the voltage across this resistor, right? In very simple terms, we can say Vs is equal to I apologize. This whole thing got shaken up. Reset the camera. Just like so. Okay. V is equal to IR. I is V over R. I is Vs over Rs, which is 10 and then 15. 10 over 15 is 0.67 amps. Okay, now the question is, what is the voltage across this resistor and these resistors? Okay, let's think about what's happening. So this current here is the same as this current here. So I'm going to rewrite I here. Okay? All right, so I can redraw the circuit again. Let me redraw this circuit. And let's look back. Let's look at the circuit as a whole. I. Okay, so now the question I'm asking is, what is the voltage across RS? What is the voltage across, or what is the voltage across R1 and R2 really? Okay, because RS is of R1 and R2. No one's really going to even ask you that, right? Because the voltage across here is the voltage across here. These are the same. So here, my is VR1. Why is VR1 plus to minus? Because current runs this way. Current drops from positive to negative. Again, this is going to be VR2. Okay, current drops from positive to negative. So how do you solve the circuit? How do you solve it? Well, we clearly know that this current is running this way, right? It's the same current. So you type in, you write in V is equal to IR. Notice V equals IR is constantly repeated, right? There's only one equation, but you're manipulating V equals IR for different situations. So V here is equal to VR1, let me erase this real quick, right? I don't want to erase it too hard and mess up my camera. VR1 is equal to I times R1, which is what? I is 0.67. What's R? R1 is 10, which is equal to 6.7 volts. VR2, R2, okay, is what? .35, okay, volts. Now, what's the significance here? So we can say it's 3.3, 3.35, it's close. 3.35 plus 10, I'm sorry, 3.35 plus 6.7, this plus this, roughly 10.05, which is approximately 10, okay? So as you notice that these two add up to 10, which is Vs. So this is 10 volts, adds up to 6.7 plus 3.3. Okay, so now you see that this is one of the things called, this is basically how you check off your work. The sum of the voltages, okay, will equal to the voltage source. So sum of the voltages used, or in your resistance, is equal to your source.